let's start with code. And also, let me ask, do you have a question? Any question? Do you have a question from everything we've discussed till this time? Okay. If you don't have a question, maybe we would just discuss what we have here and move on from there. So here, we declare the variable I as an integer variable. So what does that mean? It means whatever value you assign into I becomes an integer. That's just the idea. The memory space provided for I only accommodates integers. On the next slide, we are declaring variable f. F is a floating point variable. So it means whatever value you assign into f will be a floating point. All right. So if we assume that I assign 44.75 into I. So if I do this kind of assignment, if I say I is equal to 44.75, this value on the right-hand side of the assignment operator is a float. This is float. I'm trying to assign it into I, which is an integer. Because we said the fact that I is an integer means that anything stored inside of I will be an integer. This clearly tells us that 44.75 will not be stored inside of I, but the integer parts will be stored inside of I. So inside of I, we will have 44. Okay, this is important. Now let's try the opposite. Let's try for f. So we know that f is floating point. What if we say f is equal to 4? Now we are trying to assign an integer into f. Even though we know that f takes floating point, what will happen? Yeah, the idea remains the same. Here is what will happen. Instead of integer being stored in the floating point space of f, we will have the floating point equivalent of this integer. This is integer. This is float. So what will be stored inside of f would be the floating point of the integer 4, and that will be 4.60. This is very important. 6 zeros. 4.0 will be stored inside of variable f. So if you can keep this idea in your mind, it would easily make you understand what is going on here. So what is going on here is we define variable I as an integer, f as float, and here we are doing chaining of assignment. We are doing chaining of assignment. I'm just doing a recap of what we did last time, just to remind you of what we said about this place. So we are having chaining assignment where we are saying f is equal to I, and I is equal to float 33.3. So if we go back, we remember that we said the assignment operator is right associative. So the assignment operator is right associative. This is important. Please keep this in your mind. If you do not keep this in your mind, you will most probably fail the exam. You have to keep the associativity of all operators in your mind. So the assignment operator is right associative, which means it groups from the right. So let's look at it. F is equal to I is equal to 33. When we execute this expression. Which part executes first? The first assignment on the right hand side. So it means we execute this part first. And this part is I is equal to 33.1, 33.3. If you look at the same example that we have here, what is the result? It is 44 instead of 44.75. So because of that, we know that the result of I is equal to 33.3 is 33. This is the answer for this expression. And since it is a chained expression, it means we are assigning the left-hand side to the result of the right-hand side. We are assigning the left-hand side to the result of the right-hand side. This is important, please. We are assigning the left-hand side to the result of the right-hand side, which means the next thing you are doing now is f is equal to 33. This is the meaning of this. Now, so if we look at this, clearly it brings to us this example. It brings this example to our mind. That if we say a floating point is equal to an integer, then what we store in memory of the floating point will be the floating point equivalent of the integer. So it means it's going to be the floating point equivalent of this. So we are going to say f is equal to 33.0000000. I hope you got this. All right. Embedded assignment. So we just completed chained assignment. Now we are going to embedded assignment. This is chained assignment, where we chain the assignment operators against each other. Now, we can have chained assignment, and we can have embedded assignment in which an assignment operator exists inside an expression like this. So this is the embedded part of the assignment. So what is going on? We have k is equal to 1 plus j is equal to 1. J is equal to I. What is I? I is 1. So clearly j is equal to 1. So we replace this with 1. This expression is equal to 1. And at the same time, you know that j already took the value 1. So here we are trying to print. We are printing I. What is the value of I? I is 1. So we know this is 1. We are printing j. What is the value of j? J here was assigned to be 1. So j is 1. K, what is k? 1 plus j, which is 1. K is 2. So this is what we get for embedded assignment. By the way, it's difficult to read embedded assignment. So please, you can avoid it as much as possible. All right. L value. The assignment operator requires an L value as its left operand. What is left operand? The operand at the left-hand side of the operator. So this is the assignment operator. The assignment operator has two sides. This is the left side, this is the right side. At the right-hand side, we can have values, we can have expressions, we can have statements at the right-hand side. This could be values, this could be variables, this could be values. Here I mean constant. It could be variables, it could be expressions, it could be a number of things. But on the left-hand side here, it must be what we call an L value. This side must be an L value. What's an L value? L value usually is a variable. So L value usually is a variable. So what it means is that you can have a variable on the left-hand side of an assignment operator. You can have a variable on the right-hand side also. So you can have x, is equal to y. This is fine. We can have x is equal to 7. This is fine. You can even have a function call. You can say x is equal to y plus 2 times power 3, 2. So what you're saying is, okay, evaluate this, raise 3 to the power of 2, that is 9, multiply 9 by 2, that is 18, and then add y to it. So we can have this on the right hand side, on the right hand side. This is important, on the right hand side alone. But of the things that we have here, this is the only guy that can be on the left hand side, the variable that can be on the left hand side. So let's look at it. We cannot have power 3, 2 on the left hand side. We cannot say power 3, 2 is equal to 5. Neither can we say 2 is equal to x plus 1. This does not make sense. This will not work. So this is why we say on the left hand side of the assignment operator, we have the L value. An L value represents an object stored in computer memory, not a constant or the result of an expression. Variables are L values. Expressions such as 10 or 2 times I are not L values. So on the left hand side of the assignment operator, there are a number of things you cannot put there. Now, since the assignment operator requires an L value as its left operand, it is illegal to put any other kind of expression on the left side of an assignment operator like this. 12 is equal to I is wrong. I plus j is equal to 0 is wrong. Minus I is equal to j is wrong because of the minus operator. It's wrong because of this. So the compiler will produce an error message such as invalid L value in assignment. Now we move to compound assignment. So we've discussed embedded assignment. We've discussed chained assignment. So, and simple assignment. This is the common one. Now we move to compound. Compound assignments are the assignments that do some sort of modification to a variable's value during assignment. And here is an example. If you say I is equal to I plus 2, this is simple assignment. But there are ways to write this as compound assignments. We actually write it in a shorter way, and that is the same thing as this. So when you say I plus equal to, it is the same thing as I is equal to I plus 2. So this is called a compound assignment. Because it's no longer doing assignment alone. It is doing assignment, and also it is increasing it by the number of value here. This is called a compound assignment, plus equal. And like I told you before, we have many. We have minus equal. We have divide equal. And I think I demonstrated this to you last class. We have multiply equal. I demonstrated this to you in the previous class. And also we have, as expected, we have the remainder equal. So there are 9 other compound assignment operators, including the following. So this is plus equal, this is subtract equal, this is multiply equal, divide equal, and then this is modulus. Increment and decrement operators. So 2 of the most common operations on a variable are incrementing the variable or decrementing it. So normally if you have, let's say you have x is equal to 4. In programming, 2 of the most common operations that we do is we increase x by 1. or we decrease x by 1. So here we do -1, or here we do +1. These are common operations that we do on variables. But at the same time, we can use the increment operator. We can do this same implementation using compound assignment. I mean, that is by assigning the right hand side to 1. But this is compound assignment. There is another way for doing this same thing using increment operator and decrement operator. This increment operator is plus plus, while the decrement operator is minus minus. See, just a minute, please. Just a minute. All right. So these are increment and decrement operators. But be careful. The increment operator increases by 1. The decrement operator decreases by 1. So the plus plus operator adds 1 to its operand. So how do we use it? Let's take the case of maybe variable a. A is equal to 5. If in the next line we have a plus plus, at this line, let's say after this line, let's just use that now, not at this line, after this line, a becomes 6. This is the increment operator. It adds 1 to it. After this line, if I say a minus minus, then a becomes 5 back. E becomes 5 back. All right. The plus plus operator adds 1 to its operand. The minus minus operator subtracts 1. The increment and decrement operators are tricky to use. So if you observe when I was explaining it, I said it becomes 6 after this line. The reason is because we have 2 types of these operators. The increment operator has 2 types. The decrement operator has 2 types based on when the value changes. So they can be used as prefix or postfix. This is the important thing. The prefix changes the value now. This is important for you to keep in your mind. The prefix changes the value now. The postfix changes the value later. So prefix changes the value later. I mean, postfix changes later. Prefix changes now. So they can be used as prefix operator. Observe where it is now. In prefix, it is before the variable, before the parent. So the operator comes before the operand in prefix. But in postfix, the operator comes after the operand. They have side effects. Okay, side effect means if an operation makes modification to a variable, that is the meaning of side effect. So we say that they have side effect, which means at the end of the increment or the decrement operator, there is a change to the variable, which is their operand. So at the end of this line, there is a change to variable I. Like we had here, at the end of this operation, there is a change to variable A because A became 6. That is what we call side effect. Side effect is when there is a change to a variable after the execution of an operation. That is side effect. Evaluating the expression plus plus I, plus plus, this is pre. If the operator comes after the variable, that is post. But whenever the operator comes before the variable, it is pre. All right. Evaluating the expression plus plus I yields I plus 1. And as a side effect, it increases I. So this is side effect. It yields I plus 1 for the expression and increases I by 1. So here, let's take, for example, I is equal to 1. We print, okay, probably try this. Probably we try this. Print I. Oh, what's going on? Oh, I'm in Turkish keyword. Print I. So let's say I is equal to 0. Here we can say I now is percentage G. I plus plus okay, let's say I after I on I plus plus line is percentage G. I think this is better. So I can say after I plus plus line is this. I on plus plus I line is this, and I after plus plus line is this. All right. So I guess we have what we want. So I hope you understand what I'm trying to explain here. So here I'm trying to explain postfix. Let's write it. Because the I comes after. Okay. All right. So here we want to demonstrate for, let's move one more line. So here we want to demonstrate for postfix. We all know the value of I is equal to 0, so I wouldn't print that for you anymore. You know what is going on. So we want to do postfix example. We see the value of I just on the same line of I plus plus. It will be printed. And after that, we print immediately after I plus plus. Observe that you are not changing high. You are just printing exactly what is in high. Then next thing is we will make another announcement that, okay, now we are going to the prefix example because we finished postfix. And then we print the value of I on exactly the same line, just while we are still increasing I, and see what will happen. And then finally, we print the value of I again after that expression. So let's compile. Yes. So here is what we have for the postfix example. So I on I plus plus line is 0. Observe, I is 0. So on this line, even though we did plus plus, it still remained as 0. It didn't change. But immediately after that line, it became 1. So this is the effect of postfix. It happens after that line. It happens after that line. Now we move to prefix example. I now is 1, but on prefix example, we did plus plus I on that line, and on that line, that same line it changed to 2. Let's make more space. Yes. So yes, so for prefix, this is from here, from here. So what is the last value of I? Is in the last value of I, we have the prefix text. It is 1. So I on plus plus I line is 2. Why? Because plus plus I is prefix. It changes the value of I now. Now, I plus plus is postfix. It changes the value of I later. But plus I is prefix. It changes it now. And so by changing it now, it changes it from 1 to 2 on that same line. After that line, we try to print the value of I again, we see that it has already changed. But in prefix, it didn't change on the first line. It changed after we did the evaluation. So here is the chance for you to ask your important questions. I'm pausing for 1 minute. I mean, I'm waiting for you to think for 1 minute. If you have a question, by the way, you must practice these things. You must understand them because you have a lot of code to solve in examination and you won't have computers. So now is the time for you to try and make mistakes and ask questions. Again, no questions. Great. So again, I'll assume that you understand. If you don't have a question, then it means you must have understood. All right, so let's fire away. Okay, plus I, which is prefix, means increment immediately. I plus plus, which is postfix, means use the old value now and then increment I later. Okay, we have done the increment operator. We can move to the decrement operator now, but it's about the same thing. It's just the same idea. We can change the plus plus. Or let me just do something. Let me just give you the value of I before we start. At least so you can somehow see that on the screen. Okay. Okay. So we want to at least display the value of I, so you can see what is the value of I before the code starts. And then you see the value of I again before we start the prefix. So now we have moved to decrement operator. Let's just decorate our code. All right. So this is what we have. Okay. Yes. Here is what we have. Let's move this guy a bit lower. And this guy stays yes. So for postfix example, now that we want to start, the value of I now is 4. On the I minus minus line, I remains 4. But immediately after, oh, I forgot to change this. Oh, again, there's some down I skipped. All right. So now I is 4. That's what we have at the beginning. I on I minus minus line is 4. Why? This is here. I on minus minus line. Remember, this is postfix. So this is post decrement. Because it is going to decrement later, okay, we still use the current value of I. It is going to decrement later. So we use the current value of I. So the current value of I is still 4. But after that line, when you move to line 9, then you have the new value, and that is 3. So what happened in line 8, we can just see it now in line 9 because it did not completely happen in line 8. It did the subtraction by taking the instruction in line 8, but it did not change I in line 8. But here, it has changed the I. So let's move to the next part. So we move to prefix example for the same decrement operator. Okay. Now value of I is 3. It is the last value. Nothing has happened between then and now. So it is still 3. Now minus I, which is pre-decrement, changes 3 to 2 immediately. So that after that line, we still see that 3 has changed to 2. All right. So it's the same thing for plus and minus. So when plus or minus is used more than once in the same expression, the result can be difficult to understand. So please avoid this. Avoid something like k is equal to plus I plus j minus. So avoid this kind of expression. Though this is not really difficult, this is a bit easy to understand because we know that it does this first and then this next. It adds 1 to I and then it adds 1 to j. It changes the value of I now, so I becomes 2 now. For j j is still 2, so j will become 2 on the next line. And then for, okay, j will become 2 after this expression, but by the time it does the addition, j has already become 3. So, okay, this is somehow easy to understand. But please don't do it. Don't do it. It's going to get confusing for you. Don't put increment and decrement operator, or don't mix increment operators together in a single expression. Okay, if we have I is equal to 1, j is equal to 2, and we also try to have I plus j plus plus, this is all post increment. So the value of I is 1, the value of j is 2, and the value of k is the addition of the two of them. On this line, these are their values. If you move to the next line, then I would have increased by 1, I would be 2 on the next line. J would have increased by 1, J will be 3 on the next line. But since we're on this line, K will not change. K will be 3 immediately. Nothing happens to K on another line. Okay, please keep these things in your mind. So we come back to our precedence table. Because we have added new operators, so you need to know the change to our precedence table. The postfix operators have the higher precedence. The postfix, the ones that happen later. That means the I plus plus, I plus plus. And they have associativity of from left to right. But the prefix, which is the plus I and minus I, are second after the postfix. Please observe that postfix has higher precedence than prefix. And their associativity is opposite. It's from right to left. After that, we have the unary operators. The unary operators. And the associativity of unary operators also is from right to left. Next, we have multiplicative operators, and they have associativity of left to right. Additive, left to right, and assignment, right to left. Any question? Expression evaluation. The table can be used to add parentheses to an expression that lacks them. So what we are saying is this table can be used to decide on how to evaluate our expressions. We can say we had parentheses to the expression. Starting with the operator with the highest precedence, you can put parentheses around the operators and its operand. So here is what we have first. We have A is equal to B plus equals C plus plus minus D and so on. But we said that the postfix increment operator or decrement operator has the highest precedence. So it means we will solve this first, and that is why we will start by putting this in the parentheses first. After that, what do we have next? This is the lowest. Assignment operators are the lowest. So what do we have next? We have the prefix operators. So we put this next. And the unary operators. Observe that in position 2, we have the pre and the unary together. Let's go back. In number 2, we have the pre and the unary together. So we do them at the same time. If we have them many, you understand what we do. We follow the associativity. So we go from right to left. So we do from right when we are solving to left. So we go from right to left. All right, so here we are at this point. After that, what is the next? The division operator. The division operator is higher than the subtraction and the addition and the assignment. This is the lowest. So what do? We deal with the division operator. So we look at this expression and then we say, okay, we can now divide minus minus e by minus f. So we put them in parentheses. So we put them in parentheses. Let me erase this guy. Yes. Okay, so what next do we have? We have the subtraction and the addition. Now we have two things of equal precedence. So we break the tie by using associativity. Let's go to the previous slide to check associativity of the additive operators. Additive operators go from left to right. So we come back here and we solve from left to right. So we solve from left to right. We look at D and then we solve from left. Probably I should change the colors of my pen so that it will be easy for you to identify the groupings. Um, so from left to right. So we have these also. So we change the color, maybe we make it yellow. Yes. So we are already done to this point. So what next do we have? We are done with this. Next is the plus operator. The plus operator is still standing, but now we have this part as one. We have this part as one. The next thing we should do is to group all of them under this. So we put one big final here for this. We put this to add them together. And what do we have next? We have the compound assignment operator, and this will be the last. B plus equal this. So the current value of B, add it to the result of this expression and store it back in B. So for this, we will have an extra parenthesis. Okay, we choose green. So now we have this. So this is the entire expression. Okay, because assignment operator is right associative, we start from this first before this. So finally, we will do the last one. I hope I can still find the distinguishing color. Okay, actually, I think at this point, any color I use is fine since they are already grouped. So, and finally, stop here. I hope you'll be able to do this in exam. You need to keep in mind this precedence table. Okay, so the value of an expression may depend on the order in which its sub-expressions are evaluated. May depend. So if you have an expression of addition, it won't depend. So if you have 2 plus 5 plus 7 plus 8 minus 4, anyhow you solve it, you get the same answer. But the moment you have um, mixed operators, then you really need to be careful with the order of the expression. You really need to be careful with the order of the evaluation. Okay, C doesn't define the order in which sub-expressions are evaluated, with the expression of sub-expressions involving logical and, logical or, conditional and comma operators. So in this expression, we don't know if A plus B will be evaluated before C minus D. So this influences a number of things in our thinking, in our programming. This tells us that it is risky to have A plus plus times, it is very risky because we don't know the order of the compiler's evaluation, plus A. This is dangerous depending on what you expect your result to be. So let's say A is equal to 2. What will happen if let's assume that it goes from this one first and then this one second? So what would happen? A plus plus would be 2. So A would be 2 times plus A would be 3. But if it goes this place first and then this place, plus A would be 3. By the time it gets to the A on the left-hand side, it has changed to 3 from here. So it tries to add one more for the future, but it's already 3. So the answer is going to be 9 in this case. The answer is going to be 6 in this case. Same expression, different answers based on how the compiler evaluates the expression. So it is very dangerous to mix this kind of expressions together on the same line, especially once the expression influences its own variables. Okay, let's have 10 minutes break. I'll pause now. We have 10 minutes break and we continue from here soon. Okay, so we are back. Before we add more to the things that you have learned, Let me know. Do you have any question? Questions are very good. Any question from the things we have discussed? No question again. Okay, so order of sub-expression evaluation. Remember, we began to discuss this. We said that the order of the evaluation of sub-expression would affect the result. I showed you an example here, where from the same expression, we got 6 and we got 9. Even though we followed all the principles of precedence and associativity, we can still sometimes have wrong result based on how the compiler arranges its evaluation. So most expressions have the same value regardless of the order in which their sub-expressions are evaluated. However, this may not be true when a sub-expression modifies one of its own operands. This is the part where we had problem earlier, where an expression modifies one of its own operands. So whenever you have such a situation, then some things are becoming unpredictable. The outcome becomes unpredictable depending on how the compiler evaluates the expression. So here is an example. A is equal to 5 here. At this point, we say B is equal to A plus 2. Okay, this is simple to get. A is 5. A plus 2 is 7, and that is the value of B. So B is equal to 7. Okay, this looks sensible. But the problem is, what if the compiler starts from the right-hand side? If it starts from the right-hand side, you should just forget about 5 because A is getting a new value here. So if it starts from the right-hand side, A becomes 1. And so this becomes 1 and the B becomes 3. So here is a big problem. The answer of this evaluation of C, so the value of B becomes 3, the value of A is 1, the value of C becomes 3 minus 1, so C becomes 2. And this becomes really difficult to predict what the answer will be. So we say it is undefined. It is undefined. So to prevent problems, it is a good idea to avoid using the assignment operator in sub-expressions. Instead, use a series of separate assignments like this. So separate your assignment into different lines. And this way, the value of C will be predictable and fixed. Okay, besides the assignment operator, only the operators that modify their operands are increment and decrement. When using this also, be careful that an expression does not depend on a particular order of evaluation, like our last example, like plus plus I. I is first incremented, then the new value of I is fetched, but then discarded. So if you have something like this, I is equal to 1, okay, this makes sense. I minus minus, this makes sense because at this point, I becomes 0. But if you say I times j minus 1 without any assignment, without saying is equal to maybe k, if you don't have something like this, then this entire expression is not meaningful. It would work, it would do the evaluation, but it would have no usefulness. All right. So a slip of the finger can easily create a do nothing expression. Like if you want to type I is equal to J, but while you were trying to press equal to using an English keyboard, you press shift and it becomes I plus J. You will not have an error. Why? Because this is a sensible expression. It is mathematically correct, though it is programmatically meaningless. But the compiler may not give you any alert. So some compilers can detect meaningless expressions like this and will give you a warning that, okay, you're having a meaningless expression, but some compilers would not do that. Let's try. Um, plus two. Let's see, is there any specific example we need? Okay, we don't need any specific example. Okay, so let's see what dev C++ will say. Any error? no error, any alert, no alert. So you see in this case, let's assume we wanted to type I is equal to 2, but we pressed shift and we typed I plus 2. This is a useless expression. It has no value to the CPU, it has no value to our code, it only wastes CPU cycle, but the compiler did not catch it. So we need to be very careful. All right. Okay, so that is the end of the current chapter. If you have a question, ask now, or do not ask in the final in the midterm exam. You have the chance to ask your question now, and you must ask your question now if you have your question, so that you don't postpone your question to the final examination. No question again. It's all right. So in that case, if there are no, okay, I think I have questions. When is midterm date? You have a question about midterm. Very nice question, or no? So we will have our midterm next week. The date, I'm thinking. Okay, here is what we will do. We will have the midterm at the second class of next week. I think that is the safest way. So we can study on Monday and then we have our exam on Friday. Yes. Yes. So we have our exam on Friday. You're asking if it is 14th of July. I don't think Friday should be 14th of July. That should be 18th of July. Friday, 9 a.m., 18th of July. So I will make preparations for the room that you'll use and I'll make an announcement such that you'll know the venue before the date. Friday, 18th of July, except if something strange happens and we would have to change time. But other than that, it's going to be Friday, the 18th of July. Anybody with any question? No other question. Okay, let's continue. Selection statements. So, as we write programs, there are times we need to decide which part of our code we want to evaluate. This is as simple as common daily experience. Let's take, for example, our basic algorithm of, let's say, cooking in the morning. So, you wake up, you want to cook, you go to your kitchen, you get to a point of decision. So why is my pen not writing? So, it's sort of magical. I cannot see anything on the screen. I guess you also cannot see anything on the screen. But as I'm trying to exit, it tells me that do I want to save the marks I've made? Even though I cannot see any mark, it's asking me if I want to keep the mark. This is abnormal. If I can't mark, it's going to be really difficult to teach this chapter. Let me try again. Oh, finally. So we are here. We can mark now. So let's look at our basic life. In the morning, you wake up, you want to drink water. Let's just say you want to drink water. What do you do? Is there water? Is there water in your house? This could have two answers. Yes or no. I mean, could there be any other answer? Is there drinking water? The answer is yes or no. So if there is drinking water, what else do you need? You need a cup. Um, do you have a cup? Yes or no. So if you have a cup and you have drinking water, then you drink. So without thinking, we have already done a number of if and else statements when we wake up every day. Even this morning, you have already executed a number of if and else statements. You want to cook, you go to your kitchen. The first thing is the pot clean? If the pot is clean, then okay, we put water. If it is not clean, we wash. So these are decisions. And while we make these decisions, what we are actually doing is the part of our brain that does the execution of command would evaluate the code in a part, depending on what the answer is. So if there is water, then our brain would execute, let's go and find cup. If there is no water, our brain will think of, let's go and find water. And this is what we call selection. We are selecting the part of code in our brain that we want to execute. Is it to find cup or to find water? And so we have this also in programming. If you take your courses, for example, if you score, let's say, you have a score in this course. Let's say your score is something. Let's say your score is something. And I want to assign letter grade. I can say if you have greater than 85, so you would have probably letter grade A. And then I will give you a gift. If you did not score more than 85, but somehow you are very lucky to score more than 80, let's say I would do some things and then your grade will be B. If you have more than 75, you have something like this. And then if you score, let's say, less than 50, then it is, let's say, F. Oh, I can't write it down. So let's assume that this is F. Now, if you look at this example, it is different from the example of just yes, no, yes, no. Because with yes, no, you have two options. But there are times that you have more than two options. And this is why we are going to learn selection statements. So with selection statements, we can be able to select different parts of our code to execute based on the result of an expression, based on the result of the evaluation of an expression. When we evaluate this expression, we will determine what part of code to execute. All right, so if you can understand that, you should be able to understand what we will continue with. So far, we've used the return statement and some expression statements. But most of C's lines of code fall into three categories. We have selection, iteration, and jump. So what is selection? What I just explained to you. If the pot is clean, don't wash, put water and cook. If the pot is not clean, first clean the pot and then think about what to do next. Is there water? If there is water, get the cup. If there's no water, find water first. So this is if. Also, we have another one called the switch statement. So we will switch based on a specific value. All right, we'll see this very soon. And then we have the iteration. In iteration, we'll do a specific thing many times until we stop. This also you are familiar with it. Let's assume you don't have a dishwasher, you don't have bullashik machine, and you want to wash. What do? You put your dishes in the sink, you put water on them, and then you get, let's say, a sponge and soap, and you wash the first dish. If you wash the first dish, that does not mean that you wash all the dishes. That is the same thing as iteration. What do? You pick the next dish. You do exactly the same thing to it. You wash. And then what do? You run a new code in your head. Did I finish the dishes? If the answer is yes, then you finish. If the answer is no, you pick the next dish. That's iteration. You do the same thing several times over until the condition in your head says dishes are finished. So you should stop. So this, we also do this every day, and many times we don't know that we are human programs. All right. So next is the jump statement. Jump helps us to move from a line of code to another line of code. So let's say we are on line 15. Jump statements help us to jump from line 15 to maybe line 25. We have continue that also helps us to jump, but they are different. Continue and break are different. Go to is a specific jump. Go to says go to a specific location in the code. Maybe go to a specific line number or go to some group of code that is already named as a block. Okay, this is interesting. You will learn this as we continue. And some other statements like the compound statement, which you know, and then the null statement, a statement that is just there for being a statement. It does nothing. Any question? Those first two slides are very critical. If you could understand the explanation I gave in these two slides, you should be fine in this chapter. But if you don't understand anything, please ask me now. Anybody there? I hope you're not sleeping. Because C programming is very interesting. You should not sleep. Probably you should be watching this class now with coffee. Okay, so let's continue. Logical expressions. Several of C's statements must test the value of an expression to see if that value is true or false. Okay. Several of C's statements must test the value of an expression to see if it is true or false. Here is the example. Here we are testing. What is the score? Let's just say the score is 80, or let's say it is 81. Let's say the score is 81. What are we doing? We are testing here. Is score greater than 85? The answer is false. No. The answer is false. Okay, be very careful with this false because C does not have true or false. In C's world, the answer is 0. False is 0. Now we move to the next test and we check, is our score greater than 80? Our score is 81. We are checking it against 80. Yes, it is greater than 80. So it says, yes, it is true. It is greater than 80. And again, like I told you, C doesn't have the Boolean type. It has 0 or 1 to represent true and not true. So true is 1. Any other thing is not true. Okay. So several of C's statements must test the value of an expression to see whether it is true or false. For example, an if statement might need to test the expression if I is less than j. A true value, if the result of this expression is true, it means I is of a value that is lower than j. In many programming languages, an expression such as I less than j would have a Boolean result or a logical result. What is Boolean? True. This is Boolean. Okay, since this is your first programming language, let me just show you a very interesting thing. I mean, to demonstrate what Boolean means to you. If you've never seen Boolean in any case before, this is the Python programming language. I just want to show to you is 4 greater than 7. This is what is called Boolean. In the Python programming language, it understands Boolean. Is 4 less than 2? Okay, it's 4 less than 9. The answer to this is true. So this is the Boolean result of a logical expression. By the way, we call this a relational expression. I think we discussed this earlier in your course. So it is checking the relationship between 4 and 9. And it is saying that truly 4 is less than 9. But 4 is not greater than 7. All right. So this is what we call Boolean. But in the C programming language, you don't have Boolean. In C, a comparison such as I less than j gives an integer. So in C, keep in your mind, C has no Boolean. C has an integer equivalence for a Boolean. So 0 means false, 1 means true. Okay. These are the relational operators that we have in C: less than, greater than, less than or equal to, greater or equal to. Okay, these operators produce 0 for false or 1 for true when they are used in an expression. The relational operators can be used to compare integers and floating point numbers with operands of mixed types allowed. So what it means is relational operators allows you to mix its operand. You can say is 4 greater than 2.2. This is what is called mixed type expressions. So for this operator, we have an integer, and at the same time, we have a floating point operand. This is it. So it works, unlike the case of modulus or remainder. This works only with integer. If you put an integer and then you put a float, you would have an error. If you put a float, let's say 2.2 modulus 2.1, you would have an error. Okay. Precedence of the relational operators is lower than that of the arithmetic operators. So after the arithmetic operators, we will have the relational operators. For example, I plus j less than k minus 1 means I plus j will be evaluated, k minus 1 will be evaluated, and the result of them will be evaluated using the relational operator less than. And the relational operators are left associative, so they go from left to right. So because we said the relational operators are left associative, and we have 2 here, it means we go from left, and the result of this, we compare it to this. So the expression I less than j less than k is legal, but it does not test whether j lies between I and k. Why? Because we have already shown that it is left associative. It is only checking if I is less than j, and then it is checking if the result of this is less than k. So please don't think in mathematics term and bring that idea into C. If you write I less than j less than k in mathematics, it means that is j between I and k. But in C programming, it is completely different, and you answer most of the time at least 50% probability will be wrong. Let me explain why it will be wrong. So the 1 or 0 that is produced here is what will be compared to k. Remember, we have done this, that whenever we evaluate expressions that are grouped, the result is going to be the operand for the new expression. So I less than j is going to be compared with k. Let's do something. Let's say I is equal to 2. Let's say j is equal to 5. Let's say k is equal to 3. So let's test. Is I less than j? That is true. The answer is 1. Fine. I is 2, j is 5. Is 2 less than 5? Yes. So the answer is 1. If you expect that the next operation would be j less than k, you are wrong. Because we said what we will compare with less than k is the result of this expression, which is 1. So this means is 1 less than k. Now, observe what you're expecting. You're expecting that it should be j, whereas j is 5. If you wrote is 5 less than k, which is 3. If you say, let's remove this. Let's just write 3. If you wrote is 5 less than 3, the answer would have been false, which is 0. But now that you have is 1 less than k, which is 3, the answer is true. So you see, the answer is completely the opposite of the expected answer. And this is why you need to understand that it is not the value of expressions here. It is it is not the value of variables that are going to be used. It is the value of the expression, which is the result of the expression. So if you really want to contest if j is between I and k, this is what you should do. You should say is I less than j. So that means I is somewhere here, where j is somewhere on its right hand side, because this is number line. If this is I and j is here, so it means j is greater than I is what you are checking for. And at the same time, you are saying is j less than k. It means this is the number line, k is high on the number line, and j is somewhere low on the number line. So you are checking that j is less than k, and at the same time, j is greater than I. This is the best way to do this evaluation. So we have equality operators. We have equality operators. In many programming language, actually, we mix the equality operators with the relational operators in most programming languages. So we have less than, greater than, less than or equal to, greater than or equal to, and then not equal to. This is what we have in most programming languages, most. But C is different. C separates these two as another group of operators called the equality operators. It leaves this for as the relational operators. Okay, let's clean this slide and continue. So the equality operators are left associative. Please keep all of this in mind. They go from left to right. And also produce either 0 or 1 as their result. The equality operators have lower precedence than the relational operators. Equality operators have lower precedence than the relational operators. And because of that, the expression I less than j is equal to j less than k is equivalent to I less than j first and j less than k. So you evaluate this first before you check for their equality. This is important that you keep in your mind. It's equivalent to I less than j is equal to j less than k in parentheses. All right. This is selection. Okay, I think we are moving well. We are currently in the right thing. We are in if and if else. This is good. Okay, let's continue. We have more complicated logical expressions, and they can be built from simpler ones by using logical operator. And we already saw an example here using the logical and. This is called logical and. This is called logical and. If I read this expression to you again, you will understand why it is called logical and. This is I less than j and j less than k. This is the meaning of this expression. So it's I less than j and j less than k. This is the meaning of this. Let's think about writing a very little code. So we say I is equal to 1. Let's say j is equal to 7. Um, k is equal to 6. So we want to do something interesting. We can say int b is equal to I less than j and j less than k. So let's say we print the value of b. So let's start from here. What is the value of b? It says b is 0. Why is b 0? I less than j is 4 less than 7. Yes. Okay. Is j less than k? No. So we need the two of them to be true before we can have b to be true. So let's change the value of k to 16 and then it becomes true. So this is the answer. So we evaluate this expression and we store the result in B. We can display the result in B. So this is not equal, as we have here, not equal. So this is the not or negation operator. This is logical negation. This is logical and. This is logical or. The not operator is unary, while the remaining two are binary. So what this means is we can say not x. You cannot say y not x. If you have y not x, then you must have another operator here because this is unary. And since this is unary, it is grouped with this guy. So you must have another operator to operate on the result of this evaluation. But for and needs two operands. So you must have A and B. You must have C or D. But only for this, you must have just one operand, not E. Okay, the logical operators also produce 0 or 1 as their result because they cannot produce binary Boolean. So any non-zero operand is the logical operators treat any non-zero operand as a true value and any zero operand as a false value. So if you have 0, it means false. Anything except 0 means true. Behavior of the logical operators. Let's look at that. The not expression has the value 1 if the expression has the value 0. Okay, so probably let's continue back in our code. Let's restore our code from 16 to 6 and see the result. Okay, the result is 0. We were expecting this. What if we negate B and we say not B? what would happen? The result should be 0, but now it will change it to 1. So the negation means the opposite of the current value. Let's change the value to the opposite. That is what we have here, not B. Not B means negating the current value. All right. So not expression has a value of 1 if expression itself was value 0. Not we change it from 0 to 1, to the opposite. So the expression 1 and expression 2 have a value of 1 if the value of expression 1 and expression 2 are both 0. Expression 1 or expression 2 has value of 1 if the expression 1 or expression 2 or both has a non-zero value. In other cases, these operators produce the value 0. All right. So what we are explaining here is a bit larger than this. Let me open Paint to explain it to you. By the way, what I'm explaining to you right now is included in the scope of your course. I mean, I'm going to explain it in a bigger way. It's included in the scope of your course, so you are responsible for it in the examination. So here we have. So we say expression 1 and expression 2, or expression 2. So let's do something. Instead of writing expression 1 and expression 2, I would just write x and y. So expression 1 will be x. Let me reduce the size of my pen to tick. Okay, expression 1 is equal to x from now on, while 2 is equal to y. This is expression 2. This is expression 2. By the way, let me just clean it so nobody gets confused later. Oh, what just happened? Did I use the wrong thing? Okay. Expression 2 is equal to y. Okay, so here's what we say. We say we have x, we have y. These two are basic. You are familiar with them, x and y. So let's say we have x, we have y, we have x and y. We have x or y, and then we have not. Probably we should do not x and not y first. But okay, since not x is pretty easy, it's not going to be difficult for you, and then not y. All right, let's change the color of our pens to make things look different. Oh, okay, so we can just write any possible combination. We can say we can say 0, 0, 1, 1. I'm writing it this way because I want to have all possible combinations. 0, 1, 0, 1. So what am I doing? I'm trying to have all possible combination of x and y. Here we have 0, 0. We have 0, 1. We have 1, 0. We have 1, 1. So we have all the possible combinations. Okay, let's proceed. What is x and y? Here is the idea. Here is what is being explained in the slide. Let me go back to the slide here now. It says expression 1, which is x, and expression 2, which is y, have the value of 1 only if the value of expression 1 and expression 2 are not 0. Not 0 is 1. So the time we will have the result of this expression to be 1 is when both of the expressions are not 0. So what it means, when is both not 0? Only here is when both are not 0. So this is when we have 1. Let's go back to the slide. Now the slide says for OR, expression 1 and expression 2 would have the result 1 if any one or both of them has 1. So if any one of x or y has 1, the result of this is going to be 1. If the two of them are 1, the result is going to be 1. The only time that it is not 1 is when the two of them have 0 value. The only time that it is not 1 is when the two of them have 0 value. On other cases, these operators produce 0. So let's go back to our drawing. We say the only time that this OR will be 0 is when the two of them have 0 value. So if you understand this, then you already got the remaining answer, because the answer of the rest of the spaces in the column is the opposite of what we already have. So for this case, the answer is 0. The answer is 0. The answer is 0. Six other cases, the answer is 0. For this, the answer is 1, 1, 1. So this is OR. Keep in mind, this is OR. This is AND. Any question? Are you sure you don't have a question? Okay, if you don't have a question, then we can continue. Now, okay, this is not bad. Not x. This should be easy for you to get because it is negation of the value of x. So we just look at x and we write the negation of the value here. The negation of 0 from our last experiment was 1, 0, 1. Negation of 1 is 0. Negation of 1 is 0. For y, we continue the same thing. Negation of 0 is 1. Negation of 1 is 0. Negation of 0 is 1. Negation of 1 is 0. So if you just look at the not x, it is the opposite of the x. If you look at the not y or negation of y, it is the opposite of y. Any question? Any question? I just hope someday you would have questions. I mean, real programming questions. Okay, let's continue. Oh, it's already 10:50. Let's have 10 minutes break and we come back to continue. 10 minutes break. See you soon. All right. Everybody, I hope you are there. I think we have done enough. We already got to logical operators. So maybe I give you some time, you go and enjoy the first day of your working week. So we'll stop here. We'll stop here and we will resume from this place next time. So finally, any question? Any question? Omar, any question? Omar Jan, Onur, Tala, Tanku, any question? It's your lucky day. You should have a question. Okay. If there is no question, as usual, please write present in the chat so that I can identify that you are in class and you're not sleeping. And then I will. Okay, no question from Tala. It's all right. Okay, please write present in the chat so I will recognize that you are present and I will mark your attendance with that. Take care of yourself. I'll be closing the meeting in about 10 seconds. Write present, please.